Okay, so let's just start with y equal x squared and make sure we know what that looks like. We can plot that by just giving it lots of different points, and so if I say start at -4, go to -3, -2, -1, 0, 1, 2, 3, 4, like that. Then y, which is x squared, is going to be 16, 9, 4, 1, 0, 1, 4, 9, and 16. And if I plot those, so there's -4, -3, -2, -1, 1, 2, 3, and 4, and go all the way up here. I guess if that's 16, then right in there would be 8. Right in there would be 4, 2, and 1. Okay, so here we've got 2, 4, 6, 10, 12, 14, like that. So if I plot that, I have 0, 0, and then 1 and a 1 there, and when I go to 2, I'm up here at 4, and 9, and then finally all the way up here at 16. And so what we see is we get this, kind of missed there, but we get this parabola shape for y equal x squared. And pretty much that's the shape we always get. We're going to talk about putting in some parameters here to kind of move this around, and then I have some videos using Desmos to kind of show how things get moved around there. It's a little easier to see. But so we start with the y equal x squared, and notice that if I simply go to, and this is a parabola opening up, if I go to something as simple as y equal -x squared, well, what happens is I get, in absolute value, I get all these same points, but now instead of 16, 9, 4, and so forth, they're all negatives. And so in this case, it would be a parabola opening down. And so that's one thing, is we can decide, if we need to model something opening up, we're going to want a positive on the x squared. If we want to model something opening down, we're going to need a negative on the x squared. Now, beyond that, not even though there are a lot of data that are quadratic in nature, they certainly aren't all going to look the same. And so it could be that we need, for instance, a narrower parabola or a wider parabola. And we can get that simply by multiplying the x squared by some number, some constant a. And so what we have is that certainly if a equals 1, we get the usual x squared. Now, if a is bigger than 1, it's actually going to look narrower. Now, why narrower? Well, let's take just a couple of values here. So -1, 0, 1. And let's compare x squared. So here's x. x squared and let's say 2x squared. And we'll also add in 1/2 x squared. So x squared we get 1, 0, 1. But notice with 2x squared we would get 2, 0, 2. And with 1/2 x squared we would get 1/2, 0, 1/2. Now if you plot those points, so there's -1, there's 1, there's 2, there's 1, and 1/2. And so the original was going through here. So there's our original, x squared. But then it's way up here already if it was 2x squared. So to get there, right, well, I'll just fill that one in. Okay, so it's going to look narrower because for the same travel in x, it's going to be taller, and therefore it's going to look narrower. So I kind of messed up where I was writing. I'll have to rewrite that. And then similarly with the half, I'd be down here. And so this is 2x squared, and this is x squared, and 1/2 x squared. And you see it's going to look wider because for the same height it's shorter. And so as you keep these things going out, you know, the 1/2 looks wider. So let me rewrite that. A equal 1 is usual, x squared. A greater than 1 is narrower, and a less than 1 is wider. And again, we can turn it upside down just by making it negative values. And so that's one thing we can do. That's the ax squared. So that looks like the original model I put in the intro video so far. But now, the other thing we might have to do is, you know, I may have data that are here. Okay, and I'm going to want to, you know, put some sort of quadratic on that, it looks like. And the problem is, though, normally this end, the vertex, okay, that's the vertex, is typically at 0, 0. But we need to put it here at the point BC. And then we also have to mess with A to make it the right width. Well, so the vertex form, where it's easiest to do this, is that we would write y equal a, x minus b squared plus c. Okay, and now many textbooks will, instead of calling that b and c, they'll call it h and k, like that. And so they would write a x minus h squared plus k. Doesn't really matter. What matters is here is the shift in x for both of those. And that's the x shift. And here is the y shift. And if you remember, this is a lot like the point-slope form, right? Remember point-slope form. Okay, on that point-slope form, you had y equal of, let me make sure we're all on the same page here, of a straight line. We had our slope, x minus x1. Okay. So you could think of that as sort of the shift in x, and then plus y1. And there's the shift in y. And notice they're minus and minus. And so the x minus b, b is, well, let me write it this way. B greater than 0 is a shift to the right. Now, it's very important, though, it's still going to be minus b. So if b is 2, it's going to be x minus 2. And if b is greater than, less than 0, it's a shift to the left. And similarly, c greater than 0 is a shift up. So that's a y thing. And c less than 0 is a shift down. Okay, so that's what we'll be looking at. And, so if I see something like y equals 3 times x minus 5 squared plus 6, well, what I can tell you is the 3 says this is narrower. The 5 says move vertex. Well, let's see, and actually 3 says narrower and opens up. 5 says move vertex 5 to right. And 6 says move vertex 6 up. And so to plot this thing, I would come over here to 5, 6, and put that for my vertex. And then, draw it up like that. Now, did I make it narrow enough? I don't know. I'd probably look at something like Desmos to be sure. But, it would do something like that. On the other hand, if I have y equals negative 0.5 x plus 3 squared plus 4, well, the minus 0.5, that says it's wider and opens down. The 3, notice that's a plus 3. That's actually means then that's a negative 3, because I could write this as negative 0.5 x minus, that puts it in the right form, but then minus 3 squared plus 4. So see, it's all about that form, and that has to be a minus. So this is a negative 3, and so it says move to left 3. And then the 4 is positive, so it says move up 4. And of course, that's the vertex. So again, if I were to draw this one, let's see, move to the left 3, 1, 2, 3, there's negative 3. Move up 4, 1, 2, 3, 4. There's 4. So there's the vertex, but it opens down and it's wider. So, something like that. And again, I would probably go to Desmos to get the specifically correct answer. But I have an idea of what it looks like if I were to have data that looked like that. And so I can play with those values of A, B, and C here to get the function I want. And so, we want to work with this particular form, this vertex form. x minus b squared plus c. So that is the form we will work with to fit our data. Okay, so I guess that's good for this one.